Hey guys, so this lesson is a review of circles in the coordinate plane. It's the beginning of our conics unit, and you've seen circles before. If I back up in my lesson here, I know you've seen a circle. The definition of a circle is all points that are equidistant from the center. Some vocab words like center and radius are going to show up today, and then remember the circumference of a circle is the distance around it. In a minute, we'll write down some formulas. That formula should look very familiar, right? Pythagorean theorem. Well, it turns out that the equation of a circle in what we call standard form is a variation of the Pythagorean theorem. So x minus h squared plus y minus k squared equals r squared. We're going to utilize our skill of completing the square on this lesson as well. So lots of old things are coming back today in this lesson, but it should be a nice, easy one. So, review. Standard form of a circle. We just saw that. That was x minus h squared plus y minus k squared equals r squared, where the center is located at hk. Notice the built-in negatives, we've got to think opposites, and the radius is length r. So what is the equation for the area of a circle? This is good review for test prep, right? Area is pi r squared. And then circumference of a circle is either diameter times pi, or you can think of it as 2 pi r because twice the radius is the diameter. I like diameter times pi because kids tend to not confuse it with pi r squared too much if I write it that way. Alright, so a little bit of review. Let's identify the center and radius, and then we will sketch, which you're all in for a good show here when you try to watch me sketch. Alright, so the center is at opposite signs, remember, 2, -3. It's -3, remember, because the built-in negative, this is really y minus a -3. That's why it says y plus 3 in the parentheses. So plotting a center point at 2, -3. And then your radius length is, remember, this is radius squared. So the radius is the square root of that, so the radius length is 2. So what I do, not that you want to model your drawing after anything I do, but I draw, yep, and then this, okay, missed, okay, got. You know, I started real strong, and that's what I came up with. Alright, so I expect better of you because you're on paper. Alright, this next one. Identify the center and radius once again. So here the center is at, remember, opposite signs, -1. And this is kind of strange. There's nothing going on in the y parenthesis, so they just wrote it as y squared. So -1, 0 is the center. And then our radius length is the square root of this number, so the radius length would be 6. And, you know, I'm sick of embarrassing myself when it comes to drawing, so I might just let you guys finish this drawing by yourself. That'll be the last time you make fun of my circles. Okay. Pretend I drew a circle. Alright. Now here, I want you to write the standard form equation of a circle if I give you the center and radius. So basically we're just going to plug in the h, k, and r. So x minus h would be x minus 4, quantity squared, plus y minus k, which is 6 quantity squared, equals, and then instead of writing 9 squared, I would expect PreCalc kids to write an 81. So this is standard form. The form you often see on standardized testing is called Generalconic Form, and that's what happens when you FOIL out the x minus 4 times x minus 4 and the y minus 6 times y minus 6, and then they rearrange a bunch of terms and collect all the constants together. So that form is cruddy, basically, because it doesn't really tell you anything. But for some reason, standardized testing, they really like that form. So what we're going to find out in a moment is if they give me that form, I have to go backwards and complete the square to find the center and radius. So, yay. Alright, so here, center at -15, 3, so our parenthesis is x plus 15 squared, plus y minus k would be y minus 3 squared. Ooh, this one's fun, the point on the circle. So, having a sketch would help, you know, if I could actually draw. But -15, 3, let's pretend it's here, right? And then -15, -1 is down here. So, this is the center, and then the circle, the edge goes through here somehow. So, I think they secretly told me the length of the radius, because the distance from the center to this edge here is just a distance of 4 units, right? It's right above it vertically. So, over here, instead of 4 squared, I'm going to write 16, of course. Now, if it was not a point directly above or below it, we'd have to do a little distance formula, but that's okay. Alright, so now I want the answer in general conic form. the useless form that all the SAT and ACT tests love. All right, so we're going to start with standard form because that's the best. It's the easiest one to start with. So x minus 7 squared plus y minus 1 squared equals 16, 4 squared. And then we're going to distribute this out and get x squared. Let's see, that'd be minus 7x minus another 7x, so minus 14x plus 49. And then plus sign. And we're going to do the same idea here. We're going to distribute this out. So that would be y squared, negative y would be negative 2y plus 1. And then depending on what textbook or what test you're looking at, Generalconic Form can look a little different for different avenues. So sometimes Generalconic Form, they write these basically in standard form. So x squared plus y squared, meaning the highest exponents first, and alphabetically after that. It's kind of weird, right? Minus 2y, and then they would collect all your constants together. So since it's like early in the morning and I can't add, I should be able to add that, huh? 15 minus 16. 34. They would bring all the constants to one side is one method, and then say equals 0. But some of these terms can be rearranged. Like I've seen them where the x's are next to each other and then the y's are next to each other. I've seen it where this constant is over to the other side. So there's no like number one correct answer for what is considered Generalconic Form. It depends on your textbook basically. Anyways, it's a terrible form. So here we see it again, Generalconic Form. So what if I'm a jerk and I say I want you to find the center and radius? Well, that's a bit of a problem because I can't see center and radius length unless I'm in standard form. So we complete the square twice. We do it for the x's and the y's. So first thing I'm going to do is I'm going to collect the x's next to each other. But I'm going to complete the square on that trinomial, so I'm going to leave a blank. And then for the y's, I'm going to collect those as well. So here we go, y squared minus 2y. I'm going to complete his square as well. This constant, basically I just need it out of the way, so I'm going to move it to the other side of the equal sign by subtracting it. And then remember we added a blue blank on the left, so I'm going to also add it to the right to balance the equation out. And then same thing with the green blank. So now we can figure out what goes in all those blanks. So remember the blank for completing the square is you take half of your middle term, your b value, and you square it. So 30 cut in half is 15. 15 squared is 225. This is not a good mental math morning for me. Alright. And then half of negative 2 is negative 1. Negative 1 squared is 1. Alright. I should totally be able to add that, right? So that's 3 plus 1 is 4. Nailed it. And then we're going to factor that. So x plus 15, quantity squared. And then this should factor nicely into y minus 1 quantity squared. And then equals 4. So now I can clearly see the location of my center and the length of the radius. Center is at negative 15, comma 1. And radius length is the square root of this number, which is a dose. If you need a little refresher on completing the square, there's many lessons out there on YouTube. But the idea is for the blanks, it's half of your b term squared. And then when you go back and you factor it, you take x, and then it's just half of your b term before you squared it. So, like in this case, negative 2 cut in half was negative 1. So, it's going to get a little more complicated than that. So if you need to pause the video and go back and look at how to complete the square, or have a little discussion with your friends, then go ahead. Alright, let's take a look at this one. I'm going to collect the x's again. No, they're 30. That's boring. Alright. We're going to complete that square. Let's do the same thing for the y's. So if I bring all these y's together, and I'm going to complete that square as well. That 476 needs to move. It's in the way basically, so we're going to subtract it over here. And then those blue and green blanks we need to add to the other side of the equation to keep it balanced. Alright, so half of b squared would be 15 squared, so 225 again. And then 16 squared is 256. Let's see, 480, 481, 5. I think it's 5. Man, if it's not 5, I apologize. I should check. Pretty sure it's 5. I'm going to go with 5. Alright. So this trinomial, because we completed the square, factors into x plus 15 squared. And then this trinomial factors into y minus 16 squared. And we're going with 5, huh? Alright, so the center location is at negative 15, positive 16. And the radius is the square root of 5, which, thank goodness they don't want me to graph that, because if I can't draw a normal circle, there's no way I'm going to be able to draw a circle with an irrational radius. Nah. Alright, moving on. Ooh, that's exciting. Look at that problem. 4x squared, 4y squared, 96, 12, 441. I don't think so. But I was kind of hoping everything could be divided by a 4. Let's find out. Now, that 441 really kind of messed everything up. Now, we have a choice. We could either, we will at some point have to divide by 4. Let's go ahead and do it now. But the other option, I was tinkering with this idea, when we complete the square for the x's, what you would have had to have done is factored a 4 out of it, and then you'd have x squared minus, yeah, right, like I can do that in my head today, guys, come on, 24x, and then you're going to complete the square on that one. But the trouble is, whatever you put in this blank, oops, there's an x right here, whatever you put in this blank, which is going to be 144, it's really being multiplied by this 4. So when I go to add the other blank to the other side of the equation, I'm really adding whatever 4 times 144 is. And then at some point, I'm going to have to divide every single thing by 4. So you have to decide when do you want to deal with the fraction decimal that we're going to occur. I'm actually okay if we just go ahead and divide everything by a 4 now. Because if I divide everything by a 4, this guy is going to be a gross fraction, but I'm okay with that. The act of factoring out a coefficient for completing the square is going to come back when we do the rest of the conics work in this upcoming unit, so we will have to practice that in the near future, but if you feel like doing it now, go ahead. I'm going to divide everything by 4. So my new equation is x squared plus y squared, got some bells coming our way, minus 24x minus 3y, and then plus, I'm just going to write it as 441 over, oh, it's not a 1, 441 over 4, for now. I know that's gross. Alright, so now let's complete the square with the x's first. And then if we leave the blank, we're going to have to add it to the other side as well. Now, this gross fraction of 441 over 4, we're going to subtract that over. But I'm going to add this blue blank as well. Alright, let's keep going. Let's complete the square on the y's. Ah, a little bit of bad news. I think we're going to end up with some fraction pieces, but that's okay. So we have y squared minus 3y plus blank. Again, we got to add it over here. I'm going to have to pause the video in a minute for the pledge. Alright, so figuring out this blank for, oh, we already did the blue one, didn't we? That was 144. So 144 over here as well. Alright, so in this green blank, if we take negative 3, cut it in half, yes, it's a fraction. And then we square it. It's still going to be a fraction, but that's okay. We can handle a fraction. That's 9 over 4. Alright, so it's kind of good news, actually, because I think once we add this together, life is going to work out. Alright, so here, this trinomial becomes x minus 12, quantity squared. And then this trinomial, it's y, and then half of b would be minus 3/2, quantity squared. So I love completing the square so much. You really, like, if factoring was your hang-up, like, they all factor the same, so. Alright, there is no way I'm going to bother trying to add this in my brain, guys, so here we go. Cheating with a calculator. Oh, that's beautiful. It comes out to 36. So now I can see that the center is located at 12 3/2, or you can say 1.5 if you don't like the thought of graphing a fraction. Ordered pair, I'm with you. And the radius length would be a 6 after we square root that. So, yeah, they can get nasty, little messy numbers, fractions, but, you know, you're in PreCalc. I think you guys can handle it. This is where it starts to get good. So what if I don't just flat out tell you the pieces of information that you really need? I tell you the endpoints of a diameter. So it doesn't really matter which diameter we're talking about because there's so many on a circle, but the ends of a diameter tell you a lot of things. If you do distance formula across those two endpoints, and then you cut it in half, that'll tell you the radius. If you do midpoint, you'll know the circle. So we actually have to do both of those things. So I'm going to start by using my midpoint formula, a blast from the past, right? X plus x divided by 2, and then y plus y divided by 2. It's been a long time since we talked about midpoint. So 0 plus negative 12 divided by 2, and then negative 2 plus 4 is 2 divided by 2. So our midpoint is at negative 6, comma 1. So this is the center of your circle, which means we know h and k. There are multiple ways how we can finish this question, but I think the easiest way is just to go back to our geometry roots and say, okay, if you know, we know three things now. We know endpoints and the center. So you could do distance between the center and one of the endpoints, and then you know exactly the radius length, or if you'd prefer to go back to the two endpoints, find the diameter and then cut it in half to find the radius. I don't care. So, seems like less work if I just use the center. So now I'm going to find the distance, which if I need a little refresher, that's distance. I'm going to find the distance between the easiest points I can find. So I'm going to use the center and this endpoint right here. So the distance between those 2 points is going to be my radius. 0 to negative 6 is 6 units, so 6 squared, plus negative 2 to 1 is 3 units. I just ignore signs because I just look for physical distance. Let's see, what is that? 36 plus 9. So the radius, 45. Now, think about our goal. It doesn't say find the radius and find the center. It says write the equation in standard form. So I'm not going to bother simplifying the square root of 45 because I'm just going to throw it back into the formula where I square the radical. So leave it alone for a minute. Center is at negative 6, comma 1. So formula is x plus 6 squared plus y minus 1 squared. And then if I square a square root of 45, we get a 45. So yay, you get a little bit of freedom in how you want to progress through some questions. Oh, that's a fun one. I give you a clue of the center, that's important, and then I tell you the area. This is actually a great clue, and this is a wonderful test prep question, because remember area is pi times r squared. So if you ignore the pi's for a moment, what I know from this clue is that the radius squared is 100. So if you think backwards, that means your radius is 10. I think we're good to go, guys. They just want the standard form of the equation. So x minus 5 squared plus y minus 3 squared, and then radius is 10, so 10 squared would be 100. Looking good. Oh, another fun test prep question. This is diameter times pi, so that tells me that 6 is the diameter of my circle, which means my radius is 3. So throw in this information into our formula. X plus 15 squared, and then y minus 10 squared. If the radius is 3, 3 squared would be a 9. How fun. I know geometry is like a long time ago for some of you. A long time ago. Alright. What if we translate the function? Or I shouldn't call it function. It's not. It's a circle. We could. We can translate it right 1 unit. So if I think about what sort of shift makes things move to the right, that would be changing the h value. So instead of being located at right 16, if I translate right 1 unit, this is now going to be located at 17. So how about x minus 17 squared plus y? The y didn't change. And the radius wouldn't change, so it still equals 9. Sometimes kids want like a formula for how to apply transformations. It gets confusing because of the built-in negatives and the fact that like the right transformation is, a subtract one. So I usually just visualize where it is and where it would be if I moved the circle. So that's up to you how you want to progress through the transformations. This one's fun. I give you a picture, which I love because that means I don't have to draw it. And you should be able to identify the center and the length of the radius based on the picture. So the center location is negative 2, 4. No, negative 4. Negative 2, negative 4. And the radius length from anywhere is 1, 2, 3. So throwing all that information into my standard form equation, x plus 2 squared plus y plus 4 squared equals 9, because 3 squared 9. Be careful, sometimes on the program that we use to make these worksheets, they don't count by ones on the grid, so look really carefully. Oh, that was the end of the lesson. Alright, hope you enjoyed a refresher on circles. Great test prep, and it's a good lead into our conics unit, which I think you guys will enjoy. Lots of good algebra and geo coming your way.